ever looked up at the night sky and marveled at the vastness of it all? The twinkling stars, the swirling galaxies, the endless cosmos. It's breathtaking, isn't it? But what if I told you that most of the universe is made up of something you can't see, something that doesn't emit light, and something that we know next to nothing about? I'm talking about dark matter. It's one of the most intriguing mysteries in modern astrophysics. And today, we're going to dive deep into its history, its discovery, and the science behind it. Let's rewind to the early 20th century when scientists were just beginning to understand the structure of the universe. The story begins with a man named Fritz Zwicky, a Swiss astronomer who in the 1930s was studying the Coma cluster of galaxies. Zwicky noticed something peculiar. The galaxies within this cluster were moving at such high speeds that they should have flown apart. According to the laws of gravity, the visible matter, the stars and galaxies we could see, wasn't enough to hold them together. It was like trying to hold a group of hyperactive children together with just a few rubber bands. Zwicky proposed that there must be some unseen mass exerting gravitational influence, something he called dunkle materie, or dark matter. Fast forward to the 1970s, when astronomer Vera Rubin took Zwicky's ideas and ran with them. She was studying the rotation curves of galaxies and found that the stars on the outskirts were moving just as quickly as those closer to the center. According to the laws of physics, we would expect those outer stars to be moving slower, like how planets further from the sun take longer to orbit. But they weren't. Rubin's work provided strong evidence that dark matter was not just a wild idea, it was a real, tangible force in the universe. So what exactly is dark matter? To put it simply, dark matter is a type of matter that does not interact with electromagnetic forces, which means it doesn't emit, absorb, or reflect light. This is why we can't see it directly. It's like trying to find a black cat in a dark room. If the cat doesn't make a sound, good luck. Scientists estimate that dark matter makes up about 27% of the universe, while regular matter, everything we can see, touch, and feel, accounts for only about 5%. The rest, that's dark energy, another mysterious force that's driving the accelerated expansion of the universe. Now, you might be wondering, how do we know dark matter exists if we can't see it? That's where things get really interesting. We can infer its presence through its gravitational effects on visible matter. Think of it like this. If you're at a party and you see people dancing, but you can't see the DJ, you might conclude that the music is coming from somewhere. Similarly, astronomers observe the way galaxies move and interact, and they can tell that there's more mass present than what we can see. It's a bit like a cosmic game of hide-and-seek, where the seeker is trying to figure out where the hidden mass is lurking. One of the most compelling pieces of evidence for dark matter comes from gravitational lensing. This phenomenon occurs when a massive object, like a galaxy or a cluster of galaxies, bends the light from objects behind it. Imagine you're looking through a glass of water. The light bends as it passes through, distorting the image. Astronomers can observe these distortions and measure how much mass is needed to create them. And guess what? The mass they calculate far exceeds the amount of visible matter. It's like finding out that the person behind the DJ booth is actually a giant, invisible robot controlling the music. But here's where it gets even more fascinating. Scientists are trying to figure out what dark matter is made of. There are several candidates, but one of the leading theories involves particles called WIMPs, weakly interacting massive particles. If they exist, they would be incredibly elusive, interacting only through gravity and the weak nuclear force. Imagine trying to catch a feather in a windstorm. That's the challenge scientists face when searching for WIMPs. Experiments are ongoing, with detectors buried deep underground to shield them from cosmic rays and other interference. It's like a high-stakes treasure hunt, and every discovery could lead us closer to understanding the universe. But dark matter isn't just about what it is. It also plays a crucial role in the evolution of the universe. It's the scaffolding upon which galaxies form. When the universe was just a hot, dense soup of particles after the Big Bang, dark matter began to clump together due to its gravitational pull. This clumping created the cosmic web we see today, with galaxies forming along the filaments of dark matter. Without it, the universe would look completely different, more like a chaotic mess than the structured beauty we observe. So why should you care about dark matter? Well, understanding it is key to understanding our universe. It challenges our perceptions of reality and pushes the boundaries of human knowledge. Every time we learn something new about dark matter, we're not just uncovering the secrets of the cosmos. We're also learning more about ourselves. It's a reminder that there's so much we don't know, that the universe is full of surprises, and that science is an ever-evolving journey of discovery. As we continue to explore the cosmos, dark matter will remain one of the biggest puzzles we face. It's a mystery that invites curiosity and wonder, and it reminds us that there's always more to learn. So, the next time you gaze up at the night sky, remember that while you're looking at stars and galaxies, there's a hidden world of dark matter lurking just beyond your sight, waiting to be discovered. Who knows? Maybe you'll be the one to uncover its secrets.